Welcome back to Wickerson Studios. I'm finishing this chapter on single variable calculus, which deals with the real line and the Cartesian plane. And I think it really culminates into this final script of grafting a parabola and having fully parametric control over it. And we will end up getting to that as I slide through and show a little bit of the ability to move things and open things up and change. I've got some integer values. I have some rational values as well to start playing with some parabolas and gaining some really nice mirrored controls over shapes and lines. And I hope you'll enjoy that, because the reason I'm doing this is that there really isn't, as of yet, or at least I haven't found within a plugin yet, and I haven't been looking that hard, a means to like create a circle. You know, you take a circle, you find a point, you put it in. But I want to go back a second on this, and I want to take a look at what a circle really is, and I want to talk about that. So I'm going to take my parabola script, and I'm going to put that to disable. And I'm going to go into my circle scripts, which are here, and enable those. And what I have is a series of circles that basically creating a circle, say at center 1 and -2 on a graph, which I have available here. I think I have it coming up here if I was to select it. There's the graph. Very small, but I'm pushing it a little larger to deal with some integers instead of between 0 and 1. You could just take the radius. You could just, you basically want to find a circle at center 1, -2 with a radius 3. Now you can do that very simply by just plugging in the circle node and then making it. Have a little bit of parametric control, but nothing compared to where I'm going to show you for owning a curve and really owning a circle. And I'm very excited about this this script that I've written. I will show you just briefly. This is a massive script covering all of the real life line and Cartesian plane. And it's available on my GitHub, and I'm very proud of it. You can get it through Patreon single tier level, so you don't have to write it all. But basically, without zooming around too much, the other way is identifying a graph with the equation x squared plus y squared minus 2x plus 4y equals 4. And this is where you get into your math skills if you remember back to high school, maybe first year university. That you can observe that contains two terms. There should be a parentheses here. X squared minus 2x. So let me just go into there and correct that so it's not confusing on this, this form. Let me just go into there. X squared minus 2x. That shouldn't have a parentheses there. I should have double checked this. That contains the first of two terms of perfect squares. And once again, I've got a little typo here and slow you down to do this, but it shows you, you got to debug everything you do in Grasshopper and Python. But basically, you have x minus 1 squared equaling x squared minus 2x plus 1. And hence, you can rewrite that. Similarly, you can rewrite y squared plus 4y as y plus 2 squared minus 4. And when you rewrite that as an equation, x minus 1 squared plus y squared, y plus 2 squared equaling 3 squared, which is what it ends up equaling when you do a little bit of manipulation of the equation, you end up seeing that, yes, that's going to be at plus 1 on the x and minus 2 in the y with a radius of 3. And if you know how to read that, then you can just go in and graph that and have it. But that's not what I want to do. What I want to do is go right into the easy scripts and think about, okay, I should probably have this as a scribble tool instead of a panel tool because I don't want people changing it, and think of it as text. Basically, there's the equation we want to map. There's a way to look at it, and there's another way to think of writing it, y, solving for y. And of course, you have to solve for y plus or minus that. So when I go into here and I think about creating a domain, which goes from, I think I went from -15 to 15, but I'm going to hold it at 5. I'm going to write that script in, solving for y, and then I'm going to pull it out, and I'm going to pull it out in the y, and that's very interesting. I'm going to pull it out in the negative and the positive direction. And in doing so, I can generate, now you'll notice a little switch to the positive and negative on the 2 here will situate your top parabola with your bottom parabola, and end up writing it through an interpolated curve into a joint curve, and you end up with a circle. And with that circle, what kind of manipulation can we do with it? Well, nothing yet. Let's add some. Let's rewrite that script again here, and let's join this one. Let's rewrite this circle, and you see what has happened to that circle is I've rewritten it. I brought it in, but I'd added an a to it, which I could have added inside the inside of here or outside of here. It would have made a little bit of difference. As you start to play with the equation, because a depends if you want to square it afterwards or before it. But as I start to manipulate that through, a has a value of working at 1 to be that closed circle, but then it starts to open up as lines on each side. And I think it's interesting how it tries to interpolate together and it can't. It hits these kind of asymptotes that it can't cross over. I don't know if that's the correct term for it, but it's what I'm thinking about. But I have control in the A direction as I move through that. So let's just leave that one. And let's go down here to the next one and say, okay, what kind of manipulation do I want to do to that script again? Well, I want to add the variable b, and I want to divide by that. And in doing that, I can start to stretch it out. And you start to see how ellipses are kind of born out of this. And you see at 0, when it equals 2, it defaults out because it can't, I believe, it can't divide by, it can't divide by 0. So it's definitely not going to function at 0. It's going to default out, but you're not going to really catch it at 0. I think I have it snapping to 0. There it is. It defaults out at 0 as it snaps, but you cannot divide by a 0. So you start to find these limits, and Grasshopper solves for it. But you can see you have a really nice elliptic control over this, paired with, of course, going in and having manipulation in the A direction. Now, I can't keep my ellipse closed in that direction, and I'll have to play with that a little bit to find out why mathematically it's not working outside of the 1. But at 1, if I snap to it, it holds that nicely for the B to change that, have some good parametric control of that circle. I think my last script is one that I pull in and I say, okay, let's introduce a C, and Cx is actually a variable. It's not C times X, it's just Cx, and that's a variable that I can bring in and I can start to manipulate this in positioning it. And that's literally just moving it around. So gaining that control of where I want that circle to be situated and start and end, with the B variable still elongating or stretching it, and then the A that breaks it apart at -1 and 1 to turn it into those straight slope lines. So what control over a circle just because I've gone into the equation and wanted my parametric control? This is why you're going to want this this GH script, and I'm probably going to take it and begin with some simple plugins, work with a fellow who's interested in making something, and the fact that there's no vanilla tools to make that parabola. It's probably coming out in Grasshopper 2, but I want to have the ability to go in here and really manipulate all my geometries. I don't want to be owned by having to go in and grab a plugin, even though they're free on Grasshopper anyhow, for the most part. Let's disable that. Let's go over and see why I would do that, and then I would jump into the parabola, which really brings me to the kind of high point ending of this chapter as to how you grab that control. So let's enable that, and you'll see all these wonderful designs that are here. And I will have it so I can select whichever ones I want. I could have it so I'm only seeing what I have, but I'm going to leave them all up. So keeping with the same grid, which is nice to have. Creating a parabola at vertex 2 and -4 and a vertical axis, or identifying the graph y equals x squared minus 4x, you can write that again, and you'll see that, okay, obviously I have to bring it down and move it over. So up 2 and over 4, because you have to reverse the, not polarity, but you have to reverse the quantity from positive to negative. You can see within that, if you can actually rewrite your scripts, that you would be able to, but there is no way to grab a parabola node and just put it in the same way you did the circle and manipulate that. So let's grab a little bit of control over x squared minus 4. Let's put in x squared x minus 2. So let's put in a hard-coded that we can actually start to shift it. And then let's use the A, B, and C to actually manipulate that. So the first one being, let's go in here and say, here's our first graph. And what I've done is, just to simplify it, I'm going to go in here and hit on this node disable. So we're only dealing with a parabola in one direction, which is this one. And you'll see you get this nice control that I was doing earlier on, but you see the interconnectivity as to what's happening. And I don't really have anything but hard-coded in here, so I can't shift it. I'm just stuck with where that orients and how it skews that parabola up in this direction, so it maintains that vertex at that point, which we can recognize as 2, -4. You can mirror it if you want by going to the negative if you want. The next one I want to show is this one, which is a little more manipulation and going in and wanting the A value. And I pulled it outside of the X, outside of the square root, so I can actually have it to manipulate. And I run it through a -1 to 1 slider. And you can see that you start to have what you recognize a little more as these parabolas to control. What nice mirrored curves to have nice parametric control on, because you understand the breakdown of what a parabola is. And then the final one, I simply added the C variable to move that up and down in that axis. And at -5, I can move it there. I can move it all the way up to +5. And you start to see the connection between ellipses, mirrored, and circles themselves. And you can start to do some wonderful, beautiful geometry with this. Now, if you get a handle of your geometry straight through from where we began this entire series right here, if I jump here, was I went in and I asked the question, single variable calculus, what are the principal features of that? Then I said, let's create some points, curves, and trigonometric curves to start. I went into the first chapter of saying, what is calculus? And I started with the example of a motion of a falling rock graph, which I think you'll remember. Then independently invented, we talked about Newton and Isaac a little bit on it. The real line Cartesian plane is where it takes off for this chapter, and that's what we spend all the way through until we get to the functions chapter. And I'm going to start a new Grasshopper document under functions because this one really was owned by the line and Cartesian plane. And I went in so far as to find the properties of those. We talked a little bit about it. We talked about intervals in the real line, closed and open intervals, and dealing with a straight, linear real line. And then I think after the motion of the rock, we looked in the absolute value, which was necessary. We actually bounced the rock off the base and had it come up. So I think this series is actually pretty fantastic. Then we dealt with coordinates and graphs, so we went in, we started graphing all of these things and slowly got our mind around what was really happening between the changes in X and Y. And I ended up graphing more and more equations. I pulled assignments out of the math text that solved for not only this, I actually went in and talked about the slope of a curve, and we went in and solved for the slope of a curve in many forms. And I think the example was, I have to keep going. You see, I played off quite a few examples, dealt a little bit with obviously circles and ellipses early on. And then I went in and scripted an awful lot of things like this, which I will just take to enable. And you should be able to, well, I'll have to pull the whole thing into enable in order for it to run. So I've kind of blocked them. You can see that you start to gain some pretty cool control over some very interesting scripts. And we're ending with this one, which is pretty fantastic to build a curve system like this on that. So I thought that was fairly nice. And there's the curve that's being generated. You see how it's actually got has some beautiful curves and slopes and articulated nature to it. Now, if you get your head wrapped around this, you're definitely going to be able to wrap your head around other things. And then I ended with creating that circle and creating that parabola. So an awful lot of information in here if you enable the entire script. I've enjoyed making it. It's taken about a week. It's not unlike what I did with machine learning and single one-liners in Python. And like I said, I'm going to delve deep into functions and limits as we go towards 0 and infinity. And we're going to make some really beautiful things as we continue. So thanks very much for watching. If you want to support me, it's a tier 1 $3 level on Patreon. You can gain access to this file and all the files before it as I was building it. And keep in mind that all the videos are free and available on YouTube. And after about a month, I usually make my repos non-private, like public, so everybody can see it because I'm developing the next thing and the next thing. This series is literally for that early mathematician that just can't visualize what they're being asked to do within calculus classes, which is why I left math in the early 90s last century and then came back to this because the tools are here that once we gain control of this and we start to really ask questions three-dimensionally about what we would do with lofting and controlling these curves, you could imagine the beautiful geometries on any profession coming out of this, from sculptor to automotive design. So and space design, let's say. So thanks very much for watching. Michael Wickerson, Wickerson Studios. Follow me on Patreon, follow me on GitHub, and enjoy yourself and have fun with Grasshopper and Rhino. There's a lot of little Python scripts tucked in here also, and any one of these equations that is written in the expression node, you can start to challenge yourself to write within Python or C# to make your own plugins with them. Thanks for watching.